Good evening, everybody. Today we will discuss the next topic of the photochemistry, that is the Hoffmann Loeffler Freytag reaction. So, in the Hoffmann Loeffler Freytag reaction, our starting material is an N-haloamine having the hydrogen on the delta carbon. And for this reaction, we are applying the condition as either warming the solution or by using the strong acid or by irradiation of the acid solution with UV light. So our final product is an delta halogenated amine, and finally the delta halogenated amine undergo the cyclization and we will get this product. Okay, now we are moving into the first example. Example is an N-halo, N-chloroamine, and there is a hydrogen in the delta position. First of all, if you are treating the acid or by using the radiation or by using the base, what will happen? This is the mechanism. First of all, if you are treating with acid, the hydrogen, the chlorine in the first position is homolytically cleaved and to form a radical in the nitrogen atom, and finally the Cl minus radical is present. Cl radical is present in the reaction medium. Then if you are applying the radiation, the hydrogen in the delta position is homolytically cleaved and there is a radical is generated in the delta position, and the chlorine radical which is present in our reaction medium club with the radical in the delta position and we will get the chlorinated amine in the delta position. Then if you are treating with OH minus ion, what will happen? It will pick out the chlorine and the radical in the delta position club with the radical in the nitrogen and we will get a cycle product. And after that, we know that there is a positive charge in the nitrogen since the valency of the nitrogen is 4. So in order to eliminate the charge in the nitrogen, the hydrogen is liberated. So we will get this as the product. Now these are the some of the example for the Hoffmann Loeffler Freytag reaction. See here in this example also our starting material is an amine, and first example is a cyclic amine and it is attached to a halogen atom. Here it is a chlorine, and when we apply the acid and followed by the irradiation then followed by the base, we will get this as the product. And similarly in the next case also the amine is attached to a cyclic amine and attached to a halogen atom. And in the next example, third example, there are two nitrogen atom and one of the nitrogen atom is attached to a halogen. So these are the different examples for the reaction. Now we are moving into the next topic, that is photoisomerization. Photoisomerization means the cis-trans isomerism of the alkene is possible in the presence of the light. So first is the photoisomerization. So it is usually occurs in still beam, and we know that the trans isomer is more stable than that of the cis one, but even then during the irradiation the trans can be converted into cis and cis can be converted into trans. It is an equilibrium process and it is an opposing reaction. That means it is the reversible reaction. See the example, trans-isobenzene is converted into cis-isobenzene, and similarly cis-stilbene is converted into trans-stilbene. So the most commonly used the cis-trans isomerism by the radiation or in presence of sensitized reaction is stilbene. Okay, now these are some of the example for the photoisomerization. Here also the cis-trans isomerism occurs in presence of the radiation. Okay, sometimes the cis-trans isomerism, that means the photoisomerization, occurs in the presence of the halogen. Halogen is used for the cis-trans isomerism and using the radiations. I hope that you understood the photoisomerization reaction. Thank you.